Did you know that a single graph can tell us a lot about the star's life? It helps the classification of the stars so much simple. I'm Shweta from Astronera and I welcome you to our course, The Star Stuff. We discussed in the last lecture how the classification of the stars is important to understand the stellar evolution. In this lecture, let's see how our understanding about the stellar classification evolved till this date. In the beginning of the 19th century, great researchers from the Harvard Observatory like Annie Jump Cannon and Wilhelmina Fleming put in a lot of effort in the classification of the stars. They developed a classification scheme based on the spectra of the stars. Initially, this work started under the lead of Edward Pickering. In the 1920s, Cecilia Payne and Indian physicist Meghnad Saha demonstrated that the spectral sequence is actually a sequence in temperature. Is it getting a bit complicated now? To understand this complicated nature of the stars and their evolution, thankfully we have a master diagram which makes it all super simple. An astronomer named Hertzsprung-Russell pointed out that while categorizing the stars, regular pattern appears when the absolute magnitude of the star is plotted against its color. 2 years later, an astronomer named Henry Norris Russell independently discovered a similar regularity in graph using spectral types instead of the colors. In honor of both of these scientists, the diagram is named as Hertzsprung-Russell diagram, mostly referred as the HR diagram. On HR diagram, the luminosity or the absolute magnitude of the star is plotted against their spectral type or surface temperature. We can divide this HR diagram mainly into 4 parts. The right bottom part is where the stars having less temperature and less luminosity are plotted. The top right part is where the stars having less temperature yet more luminosity are plotted. The top left corner is where the stars having high temperature and high luminosity are plotted. And at the bottom left corner, the stars having low luminosity yet high temperature are plotted. You're probably used to the graphs in which the numbers on the x-axis are increasing from left to right. But on HR diagram, the temperature scale on the x-axis increases towards the left. This has come from original HR diagrams. No one had seriously tried to change this tradition, so it's now stuck with it. Most stars lie along the main sequence, in which our sun lies over here. Giant stars like Arcturus lie above the main sequence over here. And the supergiants like Rigel or Betelgeuse lie over here. The companion star of Sirius, which is known as Sirius B, is a white dwarf, and it lies in this region of the HR diagram. As the stars evolve, they don't stay on the same place at HR diagram. Please understand though, when I say that the stars move on the HR diagram, I mean that the star's luminosity and the surface temperature changes. So the point which represents the star on the HR diagram changes its position. This change is not at all related to how the stars physically move through the space. Remember that the HR diagram is not a physical map of the star. It is representation of the star's luminosity and temperature. So how do the stars really move on the HR diagram? Let's find out in the next lecture.